Hi, I'm Dennis Hudson here to explain how the Hudson Equilibrator works, and that's U.S. patent number 8591449B2. And I'm going to put together a very simple version of it from a schematic so that you can really understand how it goes together. These are all simple parts. It's a very simple design. And you will see from this how this more strongly positions you in the industrial market, but not only there, it gets you much deeper and much stronger in the residential market. Stay tuned. And I'd like to thank you as an alternative energy provider for taking the few minutes to watch this video. I hope and I believe it's going to be well worth your while. Also, if you want to look at the license agreement, it's right there on that website right there, whattolearn.com/solar.htm, which is to say another very pleasing aspect of this whole thing is the licensing and the cost of a license. There are no royalties, so you might want to take a look there. Or watch the licensing video that's also on the site there. Now, I make no pretense that this is a professionally done video. I'm the inventor, and sometimes you might hear kids or dogs or aeroplanes flying past or fire engines. That's because I like fresh air and I've got the window open. So I hope that's not too distracting. Now here's our first schematic, and you'll notice there's some very simple parts here. This spring, don't be put off because it's a spring. Actually, we're going to do something very unique with that spring. That could also be a volume of air that you want to compress. You will be amazed at how this works out. Over here we have what are called partition parts, and down here this is a flexible plastic bag that contains hydraulic fluid. Over here is a valve. Now this design begins with claim 13 of the patent. All the claims before that are of more boxy embodiments of the invention, and they're much more complex and have other purposes, but your license covers you for those. Alright, here we go. First we're going to put the spring in place, and let's do that this way. We take the spring, we put it up there. In fact, I'm going to have to back up a little bit so that I'm sure that you can see what we're doing and what the view is. Okay, we're looking down inside this view right here, the lower figure. Okay, the upper figure is the device, and it's scalable. It could be 1 foot across, 6 inches across, 10 feet across. It's very scalable. Alright, and down inside it, along this wall here, you notice a groove right there. You notice a groove in this wall over here. These are the partition plates that I was showing you in the other drawing, the schematic. Out here, this is a flexible bag that I pointed out, and it's got hydraulic fluid in it, and there's a valve right there. All very simple. Alright, getting back to the schematic, we put the spring in place, which, as I say, can be a volume of air that we're going to compress, and that's a different structure slightly, but for this schematic, we're going to pretend it's just a spring, okay? So we got the spring in place. Let's put in the first partition, and the way this works is it's a tongue and groove interface here between the wall and this wing of the partition, and here's the other half of the partition. You can have more than two elements, two pieces to the partition, and that's kind of important. And it fits tongue and groove into this wall. Also, the two partition parts fit tongue and groove with each other. Now let's put in the flexible bag that contains the hydraulic fluid right here, and finally we need to put the valve in where it belongs, and the valve connects to the flexible bag. Okay? Now, is that easy or what? Not only is it easy, you can see it's cheap. Now, to operate it, we just put the cover back on, okay, which I won't do here because then we couldn't see what was going on inside. And as we begin to pump fluid, hydraulic fluid, in through this valve right here, okay, that expands the bag right here, and that pushes on the partition. The partition goes upward, compressing the spring. But at the same time, please notice that the partition has expanded because the two of them are slidably interlocked, these two parts, and they expand so you get a bigger surface area where the bag contacts the partition. Therefore, your total force increases against the spring. Now this is very important, and this is what the invention at its core is really about. And whoops, I forgot to put the valve back in there on this second drawing here. There it is, it's back in place. Now to boil it down, what this means is that your input force remains constant as you compress the spring instead of the input force needing to increase. Therefore, as the spring expands and pushes the partitions back down this way, that is, as you are releasing fluid, releasing fluid in order to drive a turbine, okay, out here somewhere, that means that force remains constant. And that's a great convenience for operating any kind of equipment. You want a constant force, and you don't want a complicated bunch of adjustment devices to maintain your output. It also means the variability of your input is a non-issue. Now it's pretty easy to see how this can serve both an industrial or commercial or residential market. But in terms of the residential market, this has a special advantage. My vision of this, and you may vary, and I'm sure you will, is something, say, the size of a refrigerator, and it's got stacks of these devices, of equilibrators, occupying that volume. And the householder, the homeowner, all they have to do is divert the energy from either their solar panels or whatever other alternative energy source to charge this up. Or if they don't even have alternative energy sources set up for their home, what they can do, and you could set it up to work this way, is they just plug the device into the wall and they charge it up for storage of emergency power in the event of a blackout. So now you see why I say this can get you very deep into the residential market. Now let's talk about the other version of this, where you are compressing a volume of air. Now we have basically the same system, except instead of a spring, we have a cylinder here containing air. And here is a piston within the cylinder and a shaft coming out of the cylinder connected to the piston. This is just an extension over here of the shaft. Now let's quickly assemble this. Alright, we take our cylinder of air and we put it here. It's going to attach to that wall of the container, of the what I call the reactor. And let's go ahead and put the valve in place, because I typically forget to do that. Here's the valve back in place. And here goes the flexible bag with the hydraulic fluid in it. That's down here, and that's connected to the valve. Pardon me. And then let's put in 1/2 of the partition, and that can be multiple parts, the partition, by the way, more than 2, according to the patent. And then we can put the other half in place here, like so. And there we are. And then let's put finally the extension of the shaft here so that it contacts the partition. Alright? Now, the patent and your license provide for externalizing certain parts. And what we've done here is kind of externalize the cylinder, which is what we call our energy storage device. Or another way to look at it is the storage device extends the rear wall. This would be the nominal rear wall of the vessel. So this just sort of extends that rear wall. So there are a couple ways to look at that. Anyway, what's important here is we could not have put the gas in this space here, because then we would get dissimilar movement or dissimilar compression. The rate of compression of the gas would differ from the rate of movement of the partitions. What we need is a rectilinear space in order to compress the gas, and that's why we put it in a cylinder here, so that they move in step with each other. That's the whole point. And down here I note that in the specification, I talk about externalizing parts and the operation. It has to move in step in order for it to work. So as this moves, let's say halfway up here, or a certain amount of distance, this piston is driven that equal amount of distance. So you get the functions are comparable to each other, and therefore your input and output are at a constant. So those are a couple of approaches to using this energy storage device. I'm sure that with the genius of your technology department, you will come up with even better ways to use it. Now, a final couple of notes. If you look at Claim 13, this triangular shape, in fact you saw Claim 13 there earlier, it actually comes to a point. That's not that important. In fact, it can be truncated like this, or it can come to a point if you study the patent. And the idea of having a truncated version, of course, is so that you can fully expel the hydraulic fluid. And in one of the figures, here is actually a truncated version illustrated right here. This, by the way, is for an automotive emergency starting system. And this is one of those boxy versions before Claim 13, and believe it or not, it's the same invention, it's just a different structure. And over here is an airbag, but notice that it's contained in a rectilinear space, and this cover is removed, this wall, so that we can see inside, okay? So again, I'm Dennis Hudson, and I want to thank you once again for taking a few minutes to watch this, and I look forward to hearing from you and doing business with you soon. And please don't forget that this is a first come, first served licensing basis. It's in the licensing video there that explains it. And there are only a few licenses on the table right now. And because I'm just trying to create a market for the other licenses, these are field of use licenses, and what we've been talking about is your field of use, which is alternative energy. So they're field of use, and what I'm trying to do is increase the value of the next tranche of licenses that I sell. All right, and thanks again, and I hope you have a great day.